Good afternoon, ladies and gentlemen. It's our pleasure to participate Johor International Innovation Invention Competition and Symposium 2025. My name is Shinavin Cik. Allow me to introduce the group members. Abang Muhammad Zuhair, Muhammad Yasir Rahman, Zahir Haris. We are delighted to present our research titled Cytogenic Synthesis of Iron Oxide Nanoparticles using CYMBOPOGON species for the absorptive removal of aqueous copper 2 ions.
In this slide, we will present on introduction and backgrounds, methodology, results and discussions, and conclusion.
Presence of heavy metal has been one of the biggest concerns in Malaysian water source. Activities such as mining, agriculture, industrial, urbanization, and even natural sources such as volcanic eruption has spread a number of heavy metals. The bioaccumulation of heavy metals in the environment poses significant risks to the living organism and ecosystem. In human, prolonged exposure to heavy metals may lead to neurological damage, kidney and liver dysfunction, and reproductive toxicity. Meanwhile, the environmental consequences includes soil degradation and freshwater toxicity. Therefore, finding a method to remove heavy metals that is affordable, efficient, and eco-friendly is essential. In this work, we are investigating the biosynthesized iron oxide nanoparticle as absorbent in removing copper 2 ions from water.
Our research was guided by three main objectives. The first one is to synthesize iron oxide nanoparticles using lemongrass leaf extract as a natural reducing and stabilizing agent. The second one is to characterize both the lemongrass leaf extract and the biosynthesized iron oxide nanoparticles using appropriate analytical techniques. And the last one is to assess the absorption capacity and effectiveness of the biosynthesized iron oxide nanoparticles in removing copper 2 ions from aqueous solution.
We compared three approaches for removing heavy metals: absorption, chemical precipitation, and photocatalysis. We choose absorption because it is simple, low cost, and highly effective, especially at removing metal ions like copper 2 from aqueous solution. Other methods had limitation. Photocatalysis needs expensive materials, and chemical precipitation creates large volume of sludge. Instead of conventional adsorbents, we use iron oxide nanoparticles synthesized via a green route, which brings us to the next slide. There are several methods to synthesize iron oxide nanoparticle: green synthesis, co-precipitation, and thermodecomposition. We choose green synthesis because it operates under mild conditions, it reduces chemical waste, and it uses plant-based material like lemongrass extract as both reducing and capping agent. This makes it an eco-friendly, low-toxicity, and sustainable method, which aligns well with our absorption process for water treatment. By combining absorption and green synthesized iron oxide nanoparticles, we achieve a solution that is both effective and environmentally friendly. Okay, moving to methodology. Let's look at the procedure for lemongrass leaves extraction. The lemongrass leaves were first picked, washed, cut, and dried under sunlight until achieving constant weight. The dried lemongrass leaves were then ground into powder form. 10% of the powdered lemongrass leaves were mixed with distilled water and heated over water bath at 80 degrees Celsius for 3 hours with agitation speed of 100 rate per minute. The extract were filtered and will be used as reducing and stabilizing agent during biosynthesis of iron oxide nanoparticles. Next, 50 ml of lemongrass leaves extract were added to 0.1 mol iron trichloride hexahydrate solution, and the solution was stirred at 300 rate per minute at 70 degrees Celsius for 30 minutes. The obtained nanoparticles were separated from the solution using external magnet and washed several times using distilled water before dry in an oven overnight.
The biosynthesized iron oxide nanoparticles were then used as absorbent for aqueous copper 2 ions removal. The base absorption were conducted under incubator shaker for 1 hour by varying different operational conditions, which is initial copper 2 ion concentrations, stirring rate, and temperature.
Now let's move to result and discussion. We will first start with the characterization of lemongrass leaf extract using Fourier transform infrared spectroscopy (FTIR). FTIR analysis of lemongrass extract shows a peak at linked to hydroxyl, alkyl, aromatic, and esters group. These functional groups are crucial. They act as a natural reducing and stabilizing agent in nanoparticles formation. As for biosynthesized iron oxide nanoparticle, the peak at 619 reciprocal centimeter confirmed the formation of ferrous oxide bond, indicating successful nanoparticle creation. Several peaks which are similar to FTIR result of lemongrass leaf extract may due to the organic residue from the plant, suggested that the nanoparticles are stabilized by biomolecular of lemongrass leaf by capping them.
As for the base absorption, we will first look at the effect of the initial copper to ions concentrations on the absorption performance. In this case, we are investigating the concentration between 2000 mg per liter to 4000 mg per liter. From the result, the maximum absorption was 22.9% at 60 minutes when the initial concentration was 3000 mg per liter. At 4000 mg per liter, the absorption capacity peaked at about 175,000 and 846 mg per gram. The increase of absorption performance when increasing of the initial copper to ions concentration from 2000 to 3000 mg per liter is expected due to the higher concentration gradient resulting in the driving force for the molecules to absorb on iron oxide nanoparticles. However, increasing the concentration to 4,000 mg per liter, the active site is limited due to the absorption efficiency drop slightly.
The next variable is effect of stirring rate, which tested between the range of 100 to 200 rpm. The mechanical force enhanced the collision between copper ions and nanoparticle, thus increasing the absorption performance. However, lower the stirring rate, in this case 100 rpm, the absorption performance is the lowest, which may due to the slow diffusion of the molecules. Increasing the stirring rate increases the absorption efficiency. From this result, highest stirring rate also reduces the performance, which is expected due to deabsorption of copper ions from nanoparticles. The optimal rate was 150 rpm, balancing diffusion and absorption stability.
The last variable is the effect of temperature on absorption performance, which tested from 25 to 45 degrees Celsius. From the results, the best absorption occurred at 35 degrees Celsius. Higher temperature resulting faster absorption due to kinetic energy provided to the ions to travel and thus increase the diffusion and mass transfer. However, increasing the temperature to 45 degrees Celsius did not show any positive impact.
To conclude, we successfully synthesized iron oxide nanoparticles using lemongrass extract via a green, cost-effective, and sustainable method. These nanoparticles showed excellent absorption potential for removing copper-2 ions under optimal conditions, specifically at initial copper-2 ions concentration of 4,000 mg per liter, stirring rate of 150 rpm, temperature of 25 degrees Celsius, and an absorbent dosage of 4 mg per liter. This approach shows the feasibility of green synthesized nanomaterials to be used as adsorbents for heavy metal removal.
So these are some of the references used during the project. Thank you for your attention.
This concludes the whole presentation. Thank you very much.